Okay, today we're going to be doing polynomial division, and I'm kind of laughing a little bit because this is one thing that gives students fits. And so it's very similar to long division that we learned in the 5th grade. And you might tell me, well, I didn't do very good in the 5th grade, and I didn't do very good with long division. Well, this is not that kind of a class where we're doing remedial work. You need to be up to speed. And if you're having trouble with this, you might want to go back and look at a YouTube video on how to do long division or something like that. But for those of you who at least know the basics of long division, let's take a peek at this. And we are going to divide which one of those numbers upstairs by 3x squared. That's right, we're going to divide them all by that. There you go, and we're going to divide each one of those out individually. And 9x to the 5th divided by 3x squared. Let's see, 9 divided by 3 is going to be 3. And 5 minus 2 is 3x cubed. And let's do the same for the next term. Yeah, and let's do the next two. Okay, but I don't need that 1 for an exponent there, and I don't need this x with an exponent of 0. Much better, and that divides out all evenly and real nice. But what if it doesn't divide out all evenly and real nice? Let's look at the next problem. Okay, as you can see, that 4 is going to go real nicely into the first two terms, but the second two terms, not so much. And the x squared is going to be just fine with x cubed and x squared, but with x and the unit spot, we're going to get into a little bit of trouble there. So let's see how this all works out. Let's put 4x squared under all those terms. Okay, 4 into the 8 is going to leave us with 2. And x cubed over x squared, and that'll be 2x. And our next term is 4x squared over 4x squared. Okay, so 4x squared over 4x squared is going to cancel out, and that will leave us with what? Not 0. What's it going to leave us with? It's going to leave us with 1. Now don't cancel something out, because we say that all the time, and you know, things don't really exactly cancel out. Maybe that's not very precise mathematical terminology. So when we say cancel out, we mean 1, and 1 times what? Well, it's usually 1 times a or 1 times x or something, and the 1 ends up being superfluous. But in this case, the 1 is not superfluous. It is not extra and not needed. It is 1, and it is very much needed. Make sure you put that 1 there. Now, the next term is, well, we need to take special care in handling this. 2 over 4 is going to be 1 over 2, so we're going to need the 2 on the bottom. The 1 on top, well, let's just put it there as a marker for right now. And I know I didn't acknowledge the negative sign there, but I think now you might be able to see why I left that 1 up there, because we have x over x squared. And that means that x on top is going to disappear, so I don't want a 0 on top. I'm going to need that 1 on top. And the x squared down below is going to become just a regular x. Just like that. And 6 over 4 is going to be 3 over 2. And that is what that is going to look like when we're finished. And I know what you're thinking. Mr. McCullough, you promised us some long division, and you haven't shown us any long division yet. Well, fasten your seatbelts. Okay, this is the division of a polynomial by a binomial. And a binomial is a polynomial. Technically, a polynomial is anything more than one term, and this a binomial is 2 terms. But we usually don't call binomials polynomials. Anyways, what do we have? We have on top our dividend, and that's the thing being divided. and we have in the denominator our divisor. So the first thing we're going to do is to put everything in its proper place. The first step in the division of polynomials is to place all terms, dividend, divisor, and quotient, into its proper place. And let's look at this so that you'll understand what the proper place is. The divisor is going to go to the left of the dividing bar. The dividend is going to go under the dividing bar. And the quotient, that is the answer to this problem, is going to go above the dividing bar. So there you go, and I know I'm repeating myself, but I'm sure you don't mind. That is our divisor. This is our dividend. And right above the line is where our quotient is going to be. And our quotient is our answer, of course. And most mathematicians, when they come up with a number, they put it in this column. We're not. We're going to skip this column. You know how we do that when we're multiplying? And in the second row of our multiplication, we skip that first column. Well, we're going to do the same thing here, and you're going to see why. Step number 2. The first number in the quotient multiply by the first number in the divisor, and it must equal the first number in the dividend. Did that sound complicated? Well, I'm going to put a number up here to multiply times x, the divisor. Let's forget about -4 for right now. And it's got to equal 3x cubed. Now, what number could I put up here multiplied by x is going to be 3x cubed? It's going to be 3x squared. Now, I know I did that backwards, and it's always hard thinking backwards. It's a hard thing to do in math, thinking backwards, and that's what division is. It's just backwards multiplication. But think about that. 3x squared times x, that's right, is 3x cubed. There you go. These two numbers have to be the same. Have to. And now maybe you see why I put the quotient in this column. What column is that? Well, it's the x squared column. This is the x cubed column. And like I said, most mathematicians, they put that first number of the quotient in that column, and I'm sure there's a good reason for that. I've never figured out what it is, but I like to keep all my numbers and terms in the proper column. And there's more than one reason for that. But let's follow through with our next step. Step number 3. Multiply this number, that's the number that you put in the quotient, by all numbers in the divisor. Place that product under the dividend. And as complicated as all that sounds, that's the same thing we were doing in the 5th grade. Let's look at what we did in the 5th grade. I'm not showing you how to do long division. If you don't know how to do long division, you better get on YouTube or something and really get good at this, because polynomial division is going to make like 0 sense if you don't know long division. But anyways, this is what we did. I'm doing this to show you how the two relate to each other. Now, 12 doesn't go into 3, so we're not going to put anything in that column. 12 does go into 37. About 3 times, and we're going to multiply 3 times the divisor. And we get 36, and let's subtract that from the 37. And let's bring the next number down. And how many times does 12 go into 11? It doesn't, so let's put a 0 behind that 3. And so our remainder is 11, and so let's put that over the divisor. And that would be our answer, 30 with 11/12. Okay, is that a little bit more understandable? Now, we have this, and just like all math, let's pretend that that was in parentheses. We're going to multiply this times both of these, not just the first one. Now we concentrate on the first one because these two numbers have to match. These two numbers don't need to match, and they usually aren't going to. So anyways, we multiplied 3x squared times x. Now let's multiply it times -4. And that's -12x squared. And look at this, real nice. All of our x squares are in the proper column. So there you go. At the risk of repeating myself, this number is multiplied by the entire binomial. So we're going to have a binomial down here. This is the column that has to match. This column is whatever it is. Whatever 3x squared times -4 is, that's what it is. It does not have to match. The fourth step is to change the signs of the product. Okay, so this is positive 3x cubed. It's going to have to be negative. And this is negative 12x squared. It's going to have to be positive. There you go. What's that? We didn't do that in the 5th grade? We didn't change the sign in the 5th grade? We sure did. You changed the sign. They didn't tell you were changing the sign, but you changed the sign. Well, let's go back and look at that. We said that 12 goes into 37 3 times. That'll give us 36. And what do? Change the sign and add. Wait a second, we didn't change the sign, we subtracted. It's the same thing. And now in the 5th grade, they're not going to tell you to change the sign. It's just easier to tell kids to subtract. And either way, or you could tell 9th graders, don't change the sign, subtract. Either way, it's the same thing that you're doing. So that's kind of the same thing that we did in the 5th grade. Except in algebra, you want to change the signs instead of subtracting. Subtracting one binomial from another binomial can be really complicated, or we just don't normally think that way. And so we'll just change the sign. And as you can see, what are we going to do here? We're going to zero that out. And so as we bring all that down, that 7x squared is going to be our new term. And as you can see, isn't that just lovely? Our x squares are all in the same column. Step 6. We have a new term. Pull down the next number in the dividend. Okay, so we were working with the first two numbers in the dividend, and now we only have one term. So we're going to pull down the next term in the dividend, and that would be -32x. There you go. And now this that was in the second column was the second term, and now it's the first term. So this is the term that we want to get rid of without regard to that. We want to get rid of 7x squared. So what are we going to multiply up here in this column? You can see it's going to be an x, right? Because it's in the x column. I don't want to give away the answer, but if it's in this column, it's going to be an x. So x times x is going to be x squared. That's good. What are we going to multiply times x to get 7x squared? Well, 7x. Repeat steps 2 through 6. Okay, and let's multiply that out like we said. And of course, don't forget to multiply both of these terms and change the signs and add. And as we go along, I hope you're noticing everything is in the proper row. Cube, x cubed, x squared, everything here is an x squared. Everything in this column is an x to the 1. And if it's not, you'll know you've made a mistake. And this is actually a good check. to make sure that you haven't made a mistake. And so we're here with a lone term again. We need to bring down another term. And after you pull down the next term, you repeat the steps all over again. So what are we going to multiply in our units column? X squared, x. The next one's going to be units to get 4x. That is to get negative 4x. Okay, well, it's going to have to be a negative number to get a negative because this is positive. And we're going to need a 4. And we're not going to need an x because we already have an x. So negative 4 times x is negative 4x. Yeah, that's right. Okay, and let me get out of the way and change the signs and add. And that's negative 9. And now what do we do? Step 8. Repeat until there is a quotient in the units place. Anything left is a remainder. Okay, well, the negative 9 is left, so I guess that's going to be a remainder. So let's bring it up. Step 9. Place the remainder over the divisor. So our remainder that we have left, negative 9, we placed over our divisor, x minus 4. Remember, our divisor is x minus 4. And it's the same thing that we did in the 5th grade. Okay, let's do something a little bit more complicated. Well, actually, it won't be as complicated because you already know how to do all this. Okay, here we have a similar problem, except that the divisor has a coefficient in front of it. Quite often we just have an x here, and when we have a coefficient, of course, we have to guess differently. And we're not going to start here. Remember, we leave that blank. We're going to start here in the x squared column. So x squared times x is going to give us the x cubed. And what times 2 is going to give us 6? That's right, 3x squared. So let's multiply that out times both terms in the divisor. And our first term matches like it's supposed to. And we're going to change the sign and add. So that first term is eliminated like it's supposed to be. And we have a new first term. And so bring down the next term in the dividend. And the term that we're dividing out now has a negative sign in front of it. So we're in the x column. There's going to be an x there. There's going to be a negative to match that. And how do we get to 20? What times 2 is 20? That's right, 10. So negative 10x times 2x equals negative 20x squared. And so let's multiply that out. Okay, our first term matches again. So let's change the signs on that and add. And we have 50x, so let's bring down that last term. And to eliminate 50x, what are we going to multiply times 2x? In the units column, there's not going to be an x there anymore. It's going to be 25. 25 times 2x, 50x. Yeah, that'll be good. So let's multiply that out. Good, and let's change the signs and add that together. Okay, and our remainder is 3. So let's put that up in the quotient. Okay, and then we have a remainder of 3 over the divisor, which is 2x plus 4. And that is our answer. Now let's try one last problem. Okay, well, I think it's pretty obvious what our problem is here. We do not have our exponents in descending order, so let's correct that. Okay, that's the right order, except negative 4x is not in the right column. This is the x squared column. X cubed, x squared, x, and the units isn't in the right column either. Well, what do? We don't have an x squared. Oh, yes, we do. We have 0 times x squared. And what I normally do, of course I've been doing this a while, I just leave this space blank. You can do that, but until you get used to this, 0 times x squared is really good. The most important thing is you're still going to be working in this column. There's still going to be numbers in this column. There might not be right there, but there's going to be x squares as we're working on this. So we're going to need that space there, or you're never going to be able to do this work. So now that we have that, let's just work at this normally. Our divisor doesn't have a coefficient, and we need to get to 2x cubed. So in this column, remember I promised you that we're going to have x squares? Well, our first number is going to be an x squared, and it's going to be 2x squared, right? 2x squared times x is 2x cubed. Good. And let's multiply that out. That's good. And if I didn't have that 0x squared there, I probably would have left that out. I wouldn't have multiplied times the second term in the divisor, or I'd have done something stupid to try to make this right. And you can't make it right if you start wrong. So let's change the signs here and add. And hopefully you're not confused that negative 6x squared plus 0x squared is negative 6x squared. So let's bring down the next term. And now we're working in the x column, so our answer is going to be x. And what times 1 is going to give us negative 6? It's going to be negative 6x. That's right. Be real sure. And you've heard me say this several times, watch your signs. You don't want to do something dumb like multiply it times positive 6x and then have a positive 6x squared here and then forget to change the signs because you don't need to. Okay, so make sure we're trying to match these terms. Okay, let's multiply that out. Negative 6x times x plus 3 is going to give us this. Let's change the signs and add. We're left with 14x, and let's bring down that last term here. Okay, what times x will equal 14x? We're going to be in the unit spot, so it's going to be units. We're done with our x's. It's going to be 14. So let's multiply that out. And that'll be 14x plus 42, which means both of these match, which means when I change the signs on the bottom, they're going to zero out, which means this is our final answer. There will not be a remainder. So that's your answer, and you need to do some homework, and you need to get good at this. And as you write this stuff down, check to make sure you wrote the right numbers down, and even more important, check to make sure that every one of your signs is correct. If they're not, you're going to be in a whole lot of trouble, and you're going to do a whole lot of work and be real proud of yourself and get the wrong answer. Okay, so make sure you do your homework.